Hello and welcome to today's webinar, Cisco UCS Sysadmin Best Practices, How to Streamline Resolution Times for Common Issues, brought to you by DataLink. I'm Amanda Sharp, Marketing Admin at DataLink, and will be your moderator today. Before we begin, I wanted to cover a few housekeeping items. This webinar is designed to be interactive between you and the presenters. The webinar console you are looking at can be completely customized. You can resize or move any of the windows that you have open. If you have any questions during the webinar, you can click on the Q&A widget at the bottom and submit your question. All questions from this webinar will be captured. If you are experiencing any technical difficulties, please visit the webcast help guide by clicking on the question mark icon below the presentation window. The help guide covers common technical issues. I would now like to turn this presentation over to our presenter, Conrad Madewell. Conrad, the floor is yours.
Thank you very much. Welcome to Tech Tuesday. Today we'll be talking about UCS from Cisco. On our agenda, we'll be identifying hardware failures, some memory issues. We'll be discussing some common hardware problems and some tactics to reduce the resolution times. We'll also be talking about providing cold consultation, and then at the end we'll summarize our agenda again. So, as we approach our UCS issues, we want to go ahead and get the facts. We want to identify what series of server, for example, are we looking at a B series server, C series server, is it a standalone? Maybe it's a C series server that's integrated with a UCS manager, and then it would be considered a rack mount. We also want to confirm which UCS release that is in use. Basically, what is the startup version, or running version, excuse me. We want to confirm also the particular model of the server, including the CPU type. Some of the CPUs, such as our Echo 5 version 4 CPUs, do have different requirements than a B200M4 with an Echo 5 V3 processor. So a lot of that information would be useful. We also want to verify what kind of adapter, let's say, that server is using. For example, if it's a B200M4, you might want to check to see if it's using a 1240, a 1280. Most commonly used is the 1340 and the 1380s in the later models. That'll be your virtual interface card and your connection to the rest of the system. And of course, we always want to verify the operating system and the version. For example, are we looking at ESXi 6.0, Red Hat Enterprise? Are we looking at Microsoft Windows, Ubuntu, etc.? Now, getting those facts up front will definitely reduce a lot of Q&A and back and forth trying to capture the problem. So after we collect all that information, we try to add value by using what they call the matrix, the UCS hardware and software interoperability website. And as you can see the link there. And with this website, you can actually navigate or make an inquiry as to what is a supported configuration. And you can search by the type of server, whether it be a B series or C series. You can search by using the type of operating system that you are using or planning to use. And finally, of course, you can always select the type of adapter. So, for example, if you are using the 1340, you can drop it down for the adapter and work from there in that little drop menu. What that site will do, once again, is tell you what UCS considers supported and what is considered not supported. Most of all, that site will tell you what type of drivers are required. In the capture here, this is just an example of what we're looking for. For example, your ethnic drivers must be at a particular level. According to that matrix, using a certain combination, whether it's ESXi 6.0 with a B200M4 using a version 3 processor. Perhaps they are going down this tree and then they see the supported drivers. They want to make sure that those drivers are actually in use. Now, you have your FNIC and your ENIC. The later versions will have native or embedded drivers, so you wouldn't have to take the extra step, and they're compiled within the ISOs. But with this, you always want to make sure, especially if you're looking at connectivity issues, read and write problems with storage, etc., commonplace is to check the drivers. So now that we've figured out what drivers you're supposed to be using, depending on your operating system, as you can see in this capture here, you would want to check what drivers you currently have installed and compare the two to make sure that they are a match. Here are a few examples of the most popular operating systems that I work with, whether it be Windows, Red Hat, and of course your favorite ESXi hosts. Okay, so now that we've collected all the information about the server and the environment, including the operating system, we've confirmed that, for example, that you are using the correct version of driver, and you actually have that website / documentation to support that move or persistence of using a specific driver. The second thing we want to go ahead and do is start identifying some issues such as hardware failures. We want to go ahead and collect a show tech or tech support file. This is recommended to perform whenever a problem actually occurs. A lot of times during the troubleshooting process, this step is skipped, and actions or tasks such as reboots, decommissions, recommissions, discoveries, etc., may take place, and it makes it a little bit more difficult to try to find if it was captured within the logs. So it always is best to, when you hit that roadblock, just go ahead and collect a tech support file to capture the moment, basically, from the GUI. And as you can see here, when you log into the UCS Manager, as an example, you can go to the Admin tab, make sure that you do have the filter set to all, and you can see the tech support file there where you can create and download, of course, to a safe place such as your desktop, where you can upload it to a smart file or pass it through to the engineer or yourself, as you can analyze it and see what kind of faults are being registered within the UCS Manager. This example here shows you how you would collect the same information from a C-Series server that is not integrated with UCS Manager. Very similarly, you will have an admin tab. However, you would go to your utilities, and then you would generate a technical support data for a local download, and then follow the on-screen instructions as you generate it, and then download it to a safe place once again so you can pass it off or analyze it for any valuable log information. Okay, so now that we've pulled the show tech and we've captured the moment, we have all our information, we've logged into the UCS Manager. First thing we want to do is highlight equipment. As you notice, it's not highlighting a particular chassis or component, but more of a global view. So I like to select equipment and then go to faults to see what kind of faults we are looking at. And this gives us the, once again, this gives us the overall fault summary for the entire domain. Now, within those faults, of course, it's a great habit. Aside from the support of call home or NMS alerts that are waking you up or paging you throughout the day to let you know something is happening or a fault has been registered, this fault summary will give you a good idea of when it took place, what components are involved, and exactly what service profile may be affected. And it also gives you a good hint of what type of failure it would be. So for example, in this one you can see that we're showing equipment that's inoperable, and it gives you a good trail to follow. Likewise, in the standalone series for the C series, when you go to the SIMC, you can check out the fault summary. Now with this one, it's not as intuitive as the UCS Manager. You would want to check the sensors, the system event log, or cell, as well as the fault summary to give you a better hint of what's going on within your C series standalone server. Now, we move on to, we've considered what faults are in the summary. Now we want to go ahead and compare them by reviewing the technical support files. So this is a fairly quick high overview of how to open these and take a look at what's going on, at least to capture the main part of the information. So as you can see, you download it. For myself, I like to use 7-zip. Other folks like to use different applications. As long as you can open it up, is really what the important part is. So as I navigate using this, I open up and expand that file, and you can see that you will see a UCSM-B and a UCSM-A. This represents Fabric Interconnect A and Fabric Interconnect B. In this situation, just by looking at it, I selected UCSM-B tech support tar.gz. The one that has marked done will not give you any information. So I double-clicked on B, and lo and behold, you can see that these very important files in these orders. The one that's highlighted is SAM Tech Support Info. This is one of the biggest clues as to which Fabric Interconnect is acting as your primary. The other way, of course, is to check the cluster state. But if I was to select A, you would not see that file of SAM Tech Support Info in there, telling you that that is most likely the subordinate. So we want to go ahead and get to the point when reviewing the technical support. When you find that SAM Tech Support info, as we've discussed in the last slide, we want to go ahead and open that up. And it is very important to tell you, of course, once again, this will give you the big hint of which one is holding the management between A or B when talking about your Fabric interconnects. And if you notice here in the screenshot, I did open up Fabric Interconnect A, and as you can see, there is a software tech support info, but the SAM tech support info is not in there, which only supports that A is definitely the subordinate Fabric Interconnect. When you open up that SAM tech support info, I use Notepad++. Others may use a variety of text editors. You can quickly do a Control F and do Show Fault, which should bring you to a part of the show tech that says Show Fault Details. As you can see here, it will jump quickly to that section so you can identify what is happening, and once again, comparing it to the previous information that you know of inside the GUI's fault summary. Now, after we've reviewed the SAM tech support, we want to go ahead and open up the software tech support from within the same Fabric Interconnect file there. So looking at this, I'm still in B, and I open this up so I could take a look at Show Logging Log. This does not capture everything, but a lot of times you will find some very useful information that may have been recorded there and may have not been recorded or logged over or paged over in other logs. Now, as far as troubleshooting the hardware itself, now that we have gone down the path, we have seen the problem in the fault summary in the GUI. We've done a show fault and confirmed that even in the show tech, we are seeing that same component complaining. Additional to that, of course, you might actually find other entries giving you a hint of what took place right before that alert was flagged. So here you'd want to follow a simple flow to troubleshoot. And you basically want to ask yourself, can the management be reset? Basically, can you reset a SIMC, or if it's a standalone, as a good example, can the component be re-acknowledged? For example, should it be a blade or a chassis? Are you able to do it, or has it been done already? A lot of problems, especially hardware problems, you may find clear up after a decommission and a re-acknowledgement of the server, and at times it may also reveal an underlying issue where it fails to pass post. Another good question is we want to keep in mind is, can this be power cycled physically? If we are talking about a particular DIM, for example, you're seeing intermittent issues with a particular DIM, can it be reseated? Following the next one, can you swap it with another DIM in another working channel? For example, if you're seeing on a B200M3 DIM slot A1 showing a potential DIM failure, can you move it to, for example, H1 to see if that error will follow the DIM, or will it stay in place on A1, indicating a potential problem with the motherboard? Also, in troubleshooting the hardware, you might find on older codes that swapping or reseating a PSU or fan module could also be very, very useful in troubleshooting. So, for example, when you're trying to chase an intermittent PSU failure or fan module, we might want to ask, is it possible to exchange that with another proven module, preferably within the same chassis or from another chassis if you need to borrow it. Once again, you want to, when it comes to a bigger, more intrusive, I guess, step, instead of just a simple react, can you decommission and react, executing a deep discovery? And of course, just a good old-fashioned parts exchange with an on-site spare may also help to reduce the downtime and further isolate whether or not it's truly a single component, such as an adapter, a DIM, a PSU, or a fan module. Okay, and just to recap over these memory alerts, you have your hard errors and you have your soft errors. The basic rundown is when you have a hard error, this is undeniably most likely a hardware-related issue, and it will not be resolved unless it is exchanged with a working component. Whereas when you look at the soft errors, they're transient. They're not consistent, of course. You may see them as also, other people may consider them correctable errors. With the UCS technology, you are able to, or excuse me, the memories technology of using ECC memory, you are able to tolerate soft errors or correctable errors and even reset those counters so that you do not continue to accumulate them. Now, there was a study that Cisco performed to prove that there is no correlation between soft errors and an actual hardware failure. So when you look at this, at the very bottom part here, the hard errors are typically detected by the memory test run by the Cisco UCS BIOS at the boot time. So this is where it goes back to where you can possibly reboot or react a server to see if BIOS will catch an actual failure. Here's an example of the correctable versus the uncorrectable. At the top, you have the correctable, which shows that you have your DIM is still operable. You might check your cell logs. You can see that the status detail shows correctable ECC errors. The cell logs will definitely log the entry showing how many correctable errors and with timestamps and at what position. So it might tell you that 2 correctable errors were recorded on DIM A1. And the bottom is the uncorrectable error, which this is where it is just a hard error. And once again, it may be degraded, it may be inoperable. The point is it will have to be replaced by an RMA. Now, whether a particular error is correctable or uncorrectable, it depends on the strength of the ECC code employed in the memory system, so dedicated hardware is able to fix correctable errors when they occur with no impact on program processing. Non-correctable errors generally cannot be fixed and make it impossible for the application or operating system to continue processing. Once again, as I was saying before, there is no correlation between correctable and uncorrectable errors. With this being stated, replacing a module with correctable errors in order to avoid uncorrectable errors may create unnecessary server interruptions, which will not reduce the risk that an uncorrectable error will occur. So if you're a customer or have customers who experience a degraded memory alert for correctable errors, they should upgrade to the latest UCSM, that'll be 227.311, for example, 209 for rack standalone mode, that is for that one. If the customer does not wish to upgrade, then reset the memory error and resume operation. Of course, updating your firmware to the latest and greatest has many, many advantages. Now, as far as continuing on that discussion and clearing those correctable errors, you can simply do that by navigating into the actual server itself and then using the inventory tab and memory tab. You should be able to double click on the suspect component. And in this example, our DIM in slot A2. We're using our cell logs and we see that A2 is showing correctable errors. So we want to go ahead and clear that by simply bringing up the properties for that memory, for that DIM, and then go ahead and reset those memory errors. And you may actually see some faults clear from your fault summary when you do this. Here's an example in case that you're not comfortable or familiar with the GUI. These are the methods to clear these correctable errors using the CLI. Okay, so common hardware problems that you may hear from customers or observe yourself, of course, is the memory errors. We also have disk failures, IOM failures, RAID controller, for example, your adapter, CMOS battery, which is your lithium battery for your motherboard. You may see power on self-test fail, where it cannot apply power to the motherboard at all. You may find common reported issues with fan modules, power supplies, link down. Now, link down, of course, may indicate a potential hardware problem because of the port itself, or a simple layer 1 issue with the cabling. And of course, the dreaded motherboard failure, where we will have to actually replace the motherboard and transfer all the components from the existing server to the replacement motherboard. Now, as we started collecting the facts and verifying the drivers, making sure that we are using a supported configuration according to Cisco, all of this pretty much builds your case or your ticket to help reduce resolution times so that once again you do get the advantage of not having to go back and forth with the customer and delaying that data collection and trying to capture the problem. So with this one, you want to approach the issue with logic. One can always help reduce the resolution times, even if they're not familiar with troubleshooting UCS systems. Data collection is the key, even if you don't know exactly what you're looking at. So we want to capture the problem description. Sometimes, of course, you're repeating it back or rewording it might help. Getting a screenshot of the error or the results of a task would help. Once again, getting the facts, confirm what is the product, what is the serial number, what is our product ID, making sure everything is aligned. We want to definitely capture that technical support file right off the bat once the fault has been observed. A good question is to confirm, is this a new installation or was this completely operational and is indeed a break-fix situation? This will help you determine your approach when trying to assist the customer. So, for example, if it was an incomplete installation or, for example, a customer may have a new domain and installed some new servers, and unfortunately the servers are failing to discover, cannot associate a service profile, potentially leaving you down at that point. You might want to ask, was this working yesterday? When was the last time it was working? Because then you can kind of backtrack. If you find out that it was just a new installation, experience might lead you to go to the firmware installation to make sure you're not dealing with a board activation failure or a SIMC activation failure or something like that, or maybe even on the adapter if you notice that there is a difference between the starting version and the running version. We always want to check the entitlement, which is why we want to make sure we verify that product and the serial number as well as the PID. In case there is a requirement for an RMA, you'll have all the information that you need, and you can also verify what the contract at Cisco is going to provide you. And last but not least, we want to make sure that we can confirm that site information, which includes the shipping and the contact information, such as the name of the person in case the delivery person or even the field engineer needs to contact in case they're on the wrong side of the building or something. And also, it is very, very important to combine the last two steps. As you check entitlement, you may find that a particular component is covered under a 4-hour contract. One of the biggest challenges that are found sometimes is the site information is just not confirmed, and the contracted site may be your business office and not necessarily where you need the part delivered, like at the data center. So it's always good to do that. And if it needs to be updated, it's actually very easy to update the site install address, but it would definitely be a step to help out to make sure that that 4-hour contract actually has value, because by definition, Cisco is stating that they will maintain a certain level of inventory for you within a depot that can deliver within a 4-hour time period. If your depot is in Kentucky, but the business office, which is shown as the site address, is in Texas, there could be a problem trying to get a part from Texas to another state within 4 hours. So you'll find a lot of inventory checking to see if we can basically, borrow from other inventory if it's compatible. Now, one of the important things here is you'll find yourself neck deep in working with the logs, the GUI, and the CLI. And as you progress through your through the matrix and through your troubleshooting and your data collection, you would want to try to use that as leverage by providing a code consultation to either the customer or just to the rest of the team to let everybody know that I think we need to go ahead and take a look at these release notes here. The release notes containing open caveats. It also will show you resolved issues, resolved bugs in certain releases. So it is a very useful tool for people to support their UCS domain if they can get ahead of things. For example, they look at these release notes and say, okay, I am seeing this particular version, 3.1.2 Golf, and I'm not seeing any open caveats. I look at 3.1.2 Foxtrot, and I'm seeing a lot of open caveats. So that might actually make a huge difference in which path they wish to take. Also, you want to take a look at your download software, as it will also show what is the latest, what is suggested. A lot of customers do not want to be on the leading edge of releases, so they might want to step back to something that was very recent as the recommended version, but maybe it might be 1 or 2 releases behind that leading edge. And down here, of course, you would go through that compatibility, walk your customer or yourself through this matrix to make sure that all the dots are connected and that you provide accurate information during your code assessment. This is a huge thing to help customers avoid a lot of downtime, a lot of issues moving forward, especially if you know that certain links you can verify through the release notes, certain releases, may trigger a negative reaction out of your domain. And that is it. So in summary, we've talked about identifying some hardware errors and how to go through those logs. We talked about the popular DIM issues, some common hardware problems that you will hear about and can be addressed by using this method. The advantage of using this method, which is to reduce that resolution time, and at the same time you can recap by simply providing that code consultation to deflect any future problems. And thank you very much.
Thank you for attending today's webinar. An on-demand version of this webinar will be available within 2 to 3 days of this webcast. You will receive an email notification once the recording is available. Thank you again for participating in today's webinar. Have a good day.